Alrighty, howdy folks. I'm going to look at section 7.5 today. But the thing about this section is there is not a whole lot that I need to teach, which is new. Okay. It just so happens that 7.5 contains all the kinds of problems just put together. Okay, let me explain what I mean. Up until now, when we looked at 7.1, which is integration by parts, you look at a problem there, you just go, what technique do I apply? Well, this is in integration by parts section, man, so just apply integration by parts technique. Just about every problem there, that's what you needed to do. And 7.2 was trigonometric integrals. So there were certain things that we did there. So what I'm saying is, in every section, you kind of knew what the technique that you needed to apply. But then, if somebody just threw an integral, picked randomly a problem from 7.3, would you be able to recognize that, this is the technique I need to apply? That's not so easy, right? If you are really good at everything, yes, but it's not as obvious as to what technique that you need to use. So 7.5 is just a hodgepodge of all kinds of things with no new material. Having said that, there's only one concept, which is integrals involving absolute value that was not covered so far. So that's what I'm going to show you. How to do integrals with absolute value in them. And they are really, really important too, because they have practical significance later in your life. Cool. I don't know why I'm doing this. Just stay with me. This is interesting. What is square root of 4? Is that equal to plus or minus 2? If you said square root of 4 is plus or minus 2, guess what? What's with this thing? Well, in my classes, I jokingly say, I just write an equal sign, and then I write a small equal sign with a not equal to, and I ask, all right, boys and girls, what does indulge mean? What does this symbol mean? They say equals. What does this symbol mean? Does not equal. And then I draw this big equal sign and put a cross it off with a big thing like this and say, what is this equal to? What is this? And you're supposed to say in a southern accent, big time not equal to, right? So that's a joke. And I don't know, lots of students like that. And so I stay with it. Okay. So the idea is square root of 4 is not just equal to plus or minus 2. I just want to emphasize that it is big time not equal to. Okay. So square root of 4 is not equal to plus or minus 2. Cool. What is square root of x square? Is that equal to plus or minus x? Oh no, that's just x, man. Well, that's big time not equal to plus or minus x. Oh no, square root of x square. I know that's not plus or minus, but it's equal to x. Guess what? Big time not equal to x. Right? If x square is equal to 4, what do you think x is equal to? Now are you like, dang man, I don't want to answer your questions. I just feel so stupid right now. I have a feeling no matter what I say, you'll say that's a big time not equal to. No, don't worry about it. What is this equal to? Oh, this is actually plus or minus 2. Oh. And here is the idea. What happens is typically in high schools, apparently there are some high schools where the football coach teaches math, teaches algebra. Wow, scary. And I'm just picking one such fictitious football coach teaching math. I don't know why. Feels funny. That guy goes, all right, boys and girls, y'all agree that when x squared equals 4, that implies square root of x squared equals square root of 4. We can take square root on both sides, right? Yes, sir. Cool. And what's square root of x squared? That's equal to x, right? And what's square root of 4? Plus or minus 2, right? Ta-da! And sure enough, he started with x squared equals 4 and ended with the right answer, x equals plus or minus 2, giving a sense of confidence that, yep, I must be right in my thought process. But I'm sorry, it just so happened that the guy made two mistakes that perfectly canceled each other out. The thing is, square root of x squared is not equal to x, nor is square root of 4 equal to plus or minus 2. Okay, man, what is it then? Here is the idea. Square root of x squared, there's only one answer to that. Absolute value of x. Cool. Square root of x squared is absolute value of x. If that is the case, what should square root of 4 equal according to that? I already showed that. I should have had it. Separate text boxes. Sorry about that. Square root of 4, isn't that square root of 2 square? So according to this square root of x squared should be absolute value of x. Square root of 4 should be absolute value of 2. Right? But what is the absolute value of 2? That's equal to 2. So if you want to skip that in between absolute value of 2 and simply say square root of 4 equals 2, that's perfectly all right. So what is the key to remember here? Square root of x squared is absolute value of x, and square root of 4 is equal to 2. Just 2, not plus or minus 2. Okay, cool. Now, armed with this correct piece of information, let's rework this problem. And this time, I'll call that the correct method. We start with the same thing. X squared equals 4. Can we take square root on both sides? Yes, we can. And we get this. Now what do we say? That implies square root of x squared is absolute value of x equals positive 2. Just 2. Okay. Now, when absolute value of x equals 2, then x is equal to plus or minus 2. The general principle is if absolute value of x is equal to a and a is greater than 0, that is a very important thing, greater than or equal to 0, then x is plus or minus a. And so x is plus or minus 2. Cool? So, I don't know why. Okay, I hope you enjoyed it. Now, let's actually talk about absolute values. Every high school student in America knows the answer to these questions, and I'm confident about that one. Absolute value of 2 is equal to what? 2. Good. And people know the answer to this also. Absolute value of negative 2 is equal to what? They'll say 2. And you can ask them, why? Boys and girls, why is absolute value of negative 2 equal to 2? And they give a wonderful answer. They know the answer. Go ahead. Right? Yep. Well, that's because absolute value of negative 2 is nothing but the distance between 0 to negative 2 on the real number line. And since distance cannot be negative, 0 to negative 2, that distance is just positive 2. And so absolute value of negative 2 is equal to 2. Good. There's nothing wrong with that thinking process, but that's such a high school level way of thinking. What do you mean, man? Don't insult me like that. That's not my intention. I was exactly in the same position as you, right? Somebody taught me that, nah, don't do that. The reason is, what if I were to ask you a problem like this? Hey, if x is less than or equal to 2, so there is this variable x which takes on all kinds of values. You can pick anything that is less than or equal to 2. 1, 0, -1, -1.3, -1.2. You can think of any number that's less than or equal to 2. In those cases, what happens to absolute value of x minus 5? Right? That's the question. Okay, the distance on the real number line from 0 to no, that method doesn't work, right? So let's actually learn what absolute value of x is with a proper definition. That is, absolute value of x is equal to x if x is greater than or equal to 0, and is equal to negative x if x is less than 0. Cool? That's the definition of absolute value. Oh, come on. Well, please try to memorize this one if you already haven't. But now, here is the idea. Tell me, what is absolute value of 2? I'm not asking you to, yeah, you already know absolute value of 2 is 2. Why am I asking that? No, I'm asking you to figure out what absolute value of 2 is using this definition. And similarly, I'll probably ask you what is absolute value of -2 using this definition. So let's try to understand the definition itself. To do that, I'm going to say something. I will read that absolute value of x is equal to blah blah, that piecewise thing, but this time, wherever I see an x, I will say quantity. Okay, let's see if that makes sense. Absolute value of quantity is equal to quantity if quantity is greater than or equal to 0. Is equal to negative of quantity if quantity is less than 0. Right? Look at that. Why do I do that? It'll become clear right now. If we look at -2, what is our quantity right now? -2 is the quantity of which we are taking the absolute value. You agree? Okay. Now, to do this, keeping in mind that a quantity is -2, let's ask, is our quantity greater than or equal to 0? Nope, so don't take that path. Is our quantity less than 0? Yes, it is. Cool. So what should the absolute value of our quantity equal in this case? Negative of the quantity. Let me repeat that. Because our quantity is -2, which is less than 0, absolute value of our quantity should equal negative of the quantity. That means negative of -2. What is negative of -2? +2. That is the reason. When I first heard that, my jaw just hit the floor. I was like, oh, dang. Why didn't anybody teach me this way? Good. Now, let's see what's a big deal about this definition. Is it capable of answering our question that we posed here? If x is less than or equal to 2, then absolute value of x minus 5 equals what? Well, what does absolute value seem to depend on? Absolute value of, let me rephrase it. What does absolute value of a quantity seem to depend on? Would you agree it depends on whether the quantity is greater than or equal to 0 or less than 0? Cool. So when we are looking at absolute value of x minus 5, the quantity is x minus 5. Now, do we know whether this quantity is greater than or equal to 0 or less than 0? in this context. What is the context? Oh, we are assured that x is less than or equal to 2. If x takes on values that are less than or equal to 2, what can you say about x minus 5 itself? Would that be positive or negative? Clearly, 2 minus 5 itself is negative 3, which is negative. If you pick anything less than that, say 1 minus 5 is negative 4. Yeah, so for all values of x less than or equal to 2, x minus 5 is clearly negative. So what is the absolute value of a quantity that is negative? Negative of the quantity, right? So absolute value of x minus 5 in this context would be negative of x minus 5, which happens to be 5 minus x. As simple as that. So we can get a much clearer understanding of absolute value if we approach it with this definition. All right, and that's one concept I needed to cover. And the next concept I needed to cover is this. In what interval is x positive and x is negative? Well, I want you to use the number line 0, 0, 0, 0 like this. Would you agree? Graphically, pictorially, if we were to represent this quantity x is 0 at x equal to 0. So let's put a big vertical bar there. And the thing is, to the left, this would have a particular sign, positive or negative. And to the right, it will have the exact opposite sign. That's the behavior of the sign. Now, let's ask. To the left of 0, when x takes on values to the left of 0, which means negative 1, negative 2, and so on, what would x be? Oh, that's negative. So all I'm saying is, pictorially, just go ahead and represent all minus, 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 all this over this interval, and positive in this interval, a positive interval, greater than 0. When x is greater than 0, that's all positive. Oh, come on, duh, man, I knew that. What's the big deal about that? Cool. You're right. And so when it comes to absolute value of x, what can we say? Well, on the interval x greater than or equal to 0, notice the figure says, oh, must be positive. Therefore, in that interval, absolute value of the quantity will be replaced by the quantity itself, just x itself. However, where this is negative, in the interval where this is negative, which is x less than 0, we should say negative of the quantity, negative x. That's the point I'm trying to drive at. I'll show you many more examples. So if you didn't get that, don't worry too much about it. Next, in what interval is x minus 1 positive and negative? And I'm asking that question because I want to get to absolute value of x minus 1. On what should we replace absolute value of x minus 1 with in different intervals is the question I'm posing. But for that, again, let's do this number line thing. How you answer this is, hey, where is x minus 1 equal to 0? For what value of x? Set that equal to 0 and solve for x. You get x equals 1. So at x equals 1, put a big vertical bar. To the left, is this quantity negative or positive? There's a simple way to test that. Pick x equal to 0, for instance, which happens to be the left of 1, and plug that in. 0 minus 1 is negative. Aha! So at one point to the left of, at some point to the left of this happens to be negative. Guess what? That means every point to the left of 1, x minus 1 is negative. And automatically, everywhere to the right of 1, this is positive. That's the way I want to explain. But if you have some other ways of figure, oh, come on, you're just making a mountain out of a molehill. You're possibly right. So, but you must be able to figure out where these linear things, linear expressions are negative and positive. Okay? Now let's look at another one. Oh, yeah. Thus, x minus 1 is positive when x is greater than 1 and is negative when x is less than 1. So, what would happen to absolute value of x minus 1? On the interval x greater than or equal to 1, where this is positive, we'll replace it with the x minus 1 itself, the quantity itself. Where this x minus 1 quantity is negative, which is x less than 1, we'll replace it with a negative of x minus 1. That's the point I'm trying to get to. Okay? All right, let's do a few more. What's up with x plus 2? Where is it positive? Where is it negative? With an intention of finding out absolute value of x plus 2. Again, we'll do the same thing. Set x plus 2 equal to 0 and solve for x. You get negative 2. Put a big vertical bar. To the left negative and to the right positive. Cool. So what is absolute value of x plus 2? In what interval is this? What interval this guy is positive? The x plus 2 quantity on negative 2 to infinity. Cool. In that interval, what do we replace absolute value of x plus 2 with? Just the quantity itself, x plus 2. Whereas when this is negative, we'll replace it with a negative of x plus 2. Cool. Negative x. Yeah, it's okay. Negative x, it turns out positive here and negative there. And absolute value of negative x, and that's okay. Let's focus more on this one. Okay, I think this, for the linear ones, this is the last one. In what interval is 1 minus x positive and negative? Well, again, the number line. 1 minus x, set this equal to 0 and solve for x. You get x equals positive 1. Draw a big vertical bar at 1. To the left, positive or negative? Up until now, x minus 1, x plus 1, x plus 2, all kinds of things. Left on the negative, but watch out. This is actually positive on the left. How do I know that? Let me pick 0 for x. At 0, at x equal to 0, we have positive 1. 1 minus 0, positive 1. So here it is positive. If we were to pick x equals negative 1, we have 1 minus negative 1, positive 2. Excuse me. So, everywhere to the left, this is actually positive, and everywhere to the right, this is negative. So if we are trying to figure out what absolute value of 1 minus x is, then in the interval negative infinity to 1, this is positive. So we'll say is equal to the quantity itself when x is less than or equal to 1, whereas negative of the quantity when x is greater than 1. When x is greater than 1, this guy is negative. So we replace absolute value of the quantity with the negative of the quantity. Cool? Okay. Ooh. Now, this is interesting. Now I'm not asking about just x plus 2 or x minus 1. I'm saying, what about the product? X plus 2 times x minus 1. Or in fact, I could have complicated this by saying, tell me, what is absolute value of x squared? I could have multiplied this out. What do you get? X squared plus x minus 2. What is absolute value of x squared plus x minus 2? Would you have known how to answer that question? Well, with this process, it's easy to figure that out. And what's the method? Well, write down x plus 2. Do our analysis, real number analysis. X plus 2, set that equal to 0, you get negative 2, put a big vertical bar at negative 2. To the left is negative, right is positive. Cool. X minus 1 now. On top of this guy. Set that equal to 0, you get positive 1, put a big vertical bar at 1. To the left of 1, everything is 0, to the right is positive. Right? Okay. You just figured out just for x plus 2 and x minus 1, man. But wait a minute. If we know for these individual expressions, the individual factors where they are positive and negative, can we not figure out for the product of them? You just multiply these signs. So for x plus 2 times x minus 1, on this interval from negative infinity to negative 2, we would have a negative times negative, which is positive. Cool. However, on the interval negative 2 to 1, we have positive times negative, which is negative. And here, positive times positive is positive. Isn't that cool? So once you know this, we can clearly tell what absolute value of x plus 2 times x minus 1 ought to be. Wherever the quantity is positive, we'll say just the quantity. Wherever the quantity is negative, we'll say negative of the quantity, which I wrote as x is an element of negative infinity to negative 2 union 1 to infinity, right? All the way from negative infinity to negative 2, this guy is positive, and from 1 to infinity is also positive, and so I'm saying, I shouldn't say and, or, whether we are in this interval or in this interval, we get positive value for x plus 2 times x minus 1. So we'll replace absolute value of it with the quantity itself, whereas on the interval negative 2 to 1, we have negative of the quantity. Cool. What has this got to do with the integrals? Here is the idea. That looks like a very innocent problem. What's integral 0 to 2 absolute value of x minus 1 dx? Man, I hate absolute value, so I'm just going to remove it. No, you can't do that. Right? Here is where we can do what we just found. We just went through the real number analysis and found that absolute value of x minus 1 is x minus 1 if x is greater than or equal to 1, and negative of x minus 1 if x is less than 1. Okay, so we split this integral into two integrals, 0 to 1 and 1 to 2. Are you okay with this? We split this interval 0 to 2 into 0 to 1 and 1 to 2. That is because this tells us that on the interval 0 to 1, we need to replace the absolute value of x minus 1 with negative of x minus 1. Whereas on the interval 1 to 2, we should replace this with the quantity x minus 1 itself. The moment we do that, we got rid of the absolute value. And now this is a piece of cake to integrate. So all this discussion that I did so far is how to get rid of the absolute value sign. Okay, was the whole idea. Once you do, integration itself is piece of cake. I'm not going to insult your intelligence by discussing all these steps. I'm sure you know it, right? So that integral turns out to be 1. Now I could make it even more complicated, slightly more complicated. Negative 3 to 2 integral of absolute value of x plus 2 times x minus 1. In fact, I think if we do that real number line thing right underneath the problem, instead of how I got this, maybe I should have copied that real number line thing. You can visually see, wait a minute, if I'm integrating from negative 3 to 2, what happens? Looks like negative infinity to negative 2, right? Negative 3 to negative 2, we should have one interval. Okay, should I go back to that slide? Please bear with me. Just remember that we are going to integrate from negative 3 to 2. Okay, let me go back to that. Yeah. So here, negative 3 to positive 2, that's where we are integrating. And we notice negative 3 to negative 2 is one interval. Negative 2 to positive 1 is the second interval where this thing is negative, and 1 to 2 is the third interval. So we should actually integrate this, we should split this integral into three parts: -3 to -2, -2 to positive 1, and -2 to positive 1, and 1 to 2. And suitably replace the absolute values. Well, on the interval -3 to -2, this quantity inside the absolute value was positive, so we'll just replace it with a quantity. On -2 to 1, this was negative, so we'll replace with the negative of the quantity. Finally, positive here, so replace with the quantity. And the integral itself, simple stuff, and I think I didn't even bother to integrate that. I'll leave it to you. This was the main concept in 7.5 that is new. So I discussed it here. So let me tell you something. If I were you, I would solve every problem in 7.5. They are so challenging, some of them. That's a good test, and you should not think of it as torture. You should actually enjoy them, and they are enjoyable. Okay, so please be sure to work all the problems from there, and if you have any questions, let me know. Cool. Alrighty.